All right, so Tom invests $9,600. He invests a portion of it at a rate of 4% a year. The rest he invests in a riskier market and earns 10% a year. His total earnings were $528. How much did he invest in each place? Okay, that's what we want to know. So we're going to write a couple of equations here. Hold on, a lot of people are missing today. So, okay, here, not here, here, okay, not here, there we go. All right, Amy, did I drop one? Haley, pass back to Haley. Is this Emily? Emily, and this is, I think this is Will. Okay, there we go. Okay, so he invested a total of $9,600. He invested a certain amount in A, and he invested a certain amount in B. And so if you were to take the amount he invested in A and add it to the amount he invested in B, you would get a total of $9,600. We also have another piece of information. We have the amount of interest that he accrued, which was $528. Well, how do we calculate how much interest he got? For example, let's say he invested $100 into the 4% one. How much would he get out of that? $4 is 4% of 100. Suppose he invested, $2,000 in the 10% one. How much would he get out? What's 10% of 2,000? 200. So what you do is you take the percent times the amount. So 0.04 times the amount in A plus 0.1 times the amount in B should be equal to the $528 that he has total. So I have two unknowns. I have A and I have B, but I have two equations. If you have two unknowns, you need two equations. You learned how to solve systems last year. You did a unit called linear programming, a bunch of other stuff. What are two ways algebraically that we use to solve systems? We're not using calculator. Yep. Substitution and elimination. We're not going to use elimination in this scenario. We're going to choose to use substitution. I'm going to solve for B. B is equal to what? Very good. Negative A, so 9,600 minus A, or negative A plus 9,600. Substitution says I could take what B is equal to. B is equal to this. And I plug it in for B right there. So 0.04 times A plus 0.1 times 9,600 minus A is equal to 528. So now I have an equation with one variable, and now I can solve that. 0.04A plus, what is 0.1 times 9,600? 960. Minus 0.1A is equal to 528. Combine like terms. 0.04A minus 0.1A. Negative 0.06A. Subtract the 960 over. Negative 432. How do we solve? Divide by negative 0.06, and we get 7,200. So we have $7,200 invested at 4%. The question is, how much did we invest in each place? How do I figure out how much we invested at 10%? Yeah, you just plug it back in here. B is equal to 9,600 minus A. So if you do that, we get 2,400 at the 10%. So I set up two equations. I use my substitution principle to solve. And I go back and get the other. Piece of cake, upside down. You actually could plug it into any of the three. I chose to plug it into this one because it simply says, I want to know what B is, so it says B equals. And so I just take 9,600 minus 7,200. The answer is both of them because this is how much is in each place. Okay. All right, example 8. Great question. What quantity of a 60% acid solution must be mixed with a 30% acid solution to produce 300 milliliters of a 50% solution? So here's what we have. Yep, it's Anderson and Mr. Kozlowski. They've got two different containers here, and one's got 60% acid, the other's got 30%. We want to dump them together. One of them will dump more quickly, the other one will dump more quickly. We want a total of 300 milliliters. We want it to be exactly half acid, half water. That's kind of tricky. They dump more than 60% water or more than 30. More than 60, right? 60. Then how much? Well, we'll figure out how much by simply writing up a system of equations. Namely, we have a total amount of solution. What's the total amount of solution that we're going to have? 300. And it comes from beaker A and beaker B. Might be 100 and 200. Might be 150 and 150. Might be 250 and 50. Who knows? 120 and 80. Or 120 and 280. 120 and 180. There you go. So the question is, we now need to write something for the amount of acid because we want to restrict the amount of acid. Tough question here. We'll see if you can get it. How much acid do we want in the resulting mixture? 150. You want 50% of the total amount to be acid. So you want 150 milliliters, that is acid. You want 50%, but this is the 300 is not a percent, it's milliliters. So we kind of want to match that idea. So what percent of A is acid? 60%, so 0.6 times A. What percent of B is acid? 0.3. We're going to use substitution again. This would be a great problem for elimination. You can. Yep. B is equal to 300 minus A. Take it, plug it in. 0.6A plus 0.3 times 300 minus A is equal to 150. What's 0.3 times 300? Combine like terms, 0.6A minus 0.3A is 0.3A. Subtract the 90, I get 60. 0.3 is 3/10, so multiply by 10 thirds. 200. A is equal to 200. So I have 200 milliliters of 60%. And then how much of the 30%? 100 milliliters of 30%. And that's my answer. Not too bad, huh? Sanderson, she says she can do these in her sleep. All right. She asked for it. We'll give you a more difficult problem. Okay. John can paint a house in 32 hours. Eric can paint a house in 24 hours. How long does it take them to paint the house together? What might some people do for this example? Adam, yeah. Does it make sense? Does it make sense that it would take them together 56 hours? Why is that absurd? It takes them more time together than it did by themselves. If that's the case, they probably should be friends or working together. All right, so let's switch that. What else do you think might people do right away to solve this problem? Yeah, Adam, divide by 2, find the average. Well, if you find the average, it's 28. So why is 28 absurd? Eric's still slower. Faster for John, but Eric's still slower. The answer's got to be less than 24, doesn't it? It's got to be less than 24. So one is applying paint and the other one's applying a thin paint. Totally possible. According to the problem, we assume that they are a cohesive group and then they're working together and they're doing the same thing. So we would hope that. If you like, we could change the problem, make it different. Yeah. Okay. So here's where this idea comes from then. It comes from this idea of rate is equal to distance over time. Or rather, in this case, instead of covering a distance, we are doing work. So rate is equal to the amount of work we do divided by the time in which we do it. For example, John's rate is equal to how many houses does he paint? One house in how many hours? 32. That's John's rate. Eric's rate is equal to how many houses does he paint? One house in how many hours? 24. So John's rate is 1 over 32. Eric's rate is 1 over 24, right? Now, how many houses are they going to paint? They're just painting one house. So Eric, who's going to do more of the work? Eric, because he's faster. So Eric might do 60%. Then John would do 40%. Either way, no matter what the ratio is, it's going to add up to 1 or 100%. Okay, so it's going to add up to 1. So we're going to paint one house. And we're going to take the amount of work, okay, that John does. And we're going to add it to the amount of work that Eric does. Well, my equation right now is solved for rate, not work. So how would I solve this equation for work? Multiply by time. So rate times time is equal to the amount of work that you get done. The time that it takes them to finish the house, are they going to finish at the same time or different times? If they're working together, we would hope that when they're done, that they both stop because they say, we're done. And they don't start painting over each other's spots, okay? But that when they finish together at that same time. While they're working, are their rates the same or different? They're different. Their combined rate might be the same, but they're different. So the time is the same. So what is John's rate? 1 over 32 times, do we know how much time it takes them together? No. Plus, what's Eric's rate? 1 over 24 times time is equal to 1. So you can see from this scenario, we simply say work is rate times time. So we set up two sections. John's work is rate times time. Eric's work is rate times time. And then we just solve it. 1 over 32 times t over 1 is t over 32. Plus t over 24 is equal to 1. How do I solve an equation of that nature? Common denominators. What is a number that both 32 and 24 multiply to? on, you good number sense people. Starts with a 90, ends in a 6. Very good. All right. So 32 times what is 96? 3. So you would have 3t. And 24 times what is 96? 4. So I found a common denominator of 96. 3t plus 4t is 7t over 96 is equal to 1. How do I solve for t? And multiply by the reciprocal. So we multiply 96 and we divide the 7, which is multiplying by the reciprocal. So there we go. We have t is equal to 96 over 7, which is approximately 13.7 hours. Does that sound about reasonable? Take some 13.7. Let's say they both painted a house in 24 hours and they were working together. What would it take them then? 12. They each do half a house in 12 hours. So that's easier. So that's a way you could kind of gauge if this number is appropriate. Seeing how John's slower, it takes him a little bit more time. Let's try another work one that's a little bit different. We didn't. You see, they are house painters that have been working individually. And when they quote their rates, they give the number of hours it takes them to paint the house. Now they've decided to do one job together. So, again, although you try to draw the realistic inference from here, just doesn't seem to work. Sorry. They know their rates. They're now choosing to work together. They didn't just paint and time themselves and then go back and do it over again. No, not at all. Okay. Yeah, so somehow Matt jumped in here instead of John. It should be John. So John and Sue can paint a house in 5 hours if they work together. How is this different than the last problem? We know the time, right? And they're faster. They have a smaller house and they're using spray guns. Let's say. I don't know, whatever. If John can paint a house twice as fast as Sue, how long would it take John to paint a house alone? Do we know John's rate? He's twice as fast as Sue. We're not going to infer from the previous problem. We're the new people altogether. Okay, new people. I know. Well, so we'll say John's rate. We don't know it. We'll say his rate is one house in X hours. Okay, so one house in X hours. So what would Sue's rate be? One house in 2x hours. If it takes her twice as long, we would need double the hours below there, right? So if it took John, 10 hours, it would take Sue 20 hours, okay? So we've got that all set up. So how many houses did they paint? Painted one house. So we need John's work, we'll spell John like it wasn't a problem, plus Sue's work, and that should be equal to 1. What is our formula for work? Work is equal to rate times time. Do we know their rates? We know expressions for them, but we don't know the exact rate. That's what we'll be solving. Do we know the exact time? Yeah, they took 5 hours. So we set it up. John's work would be his rate, which is 1 over x times, how much time? 5. Plus, what's Sue's rate? 1 over 2x times time? 5. That should be equal to 1. So I have 5 over x plus 5 over 2x is equal to 1. How do I solve this kind of equation? Common denominators. What's the common denominator? Emily! 2x multiplied top and bottom by 2. And we get 10 plus 5 over 2x is equal to 1. Or 15 over 2x is equal to 1. X is in the denominator. How do you solve if x is in the denominator? Just cross multiply. What's 2x times 1? 2x. What's 15 times 1? 15. So if 2x is 15, what is x? 7.5. Does that tell us John's rate or Sue's rate? John's rate. So how long would it take John to paint a house alone? 7.5 hours. Sue, it would take 15 hours. Yep. And that's that. That's that. Because we solve for x, and when we look for where x came from right here, 1 over x. So that's the way we set it up. Some people would set up Sue to be x, then John would be 1/2 x. But then you have a 1/2 in the denominator, and that kind of confuses. So everybody's different how they set it up. Okay, so I have your assignment ready to go. Goodbye, YouTube Nation. By the way, soccer boys, if you're watching, hopefully you are. We hope that you won your game. Is anybody else gone? Tennis, Mercedes, and Rachel. Rachel who? Raquel! Oh, you're not even watching. Shout outs to people who don't even take this class. Wow. Raquel, I tell you what, if you watch this video, don't tell her. Don't tell her, okay? Promise not to tell her. The key word is platypus, okay? If you watch this video and you come back, share the key word with me, I'll buy a candy bar. So we'll send that challenge to her. Will she be willing to watch a 25-minute video on math? We'll say that we're not going to tell her it's at the end. We're going to say it's somewhere in the video. Okay, that's the key word. Are you guys going to share the word with her? If I find out